Hello, good morning, dear students. Good morning to all.
Good morning, sir.
Okay, so whether all are joined or not, so only 11 members are joined. Some more people are to be joined because this is important topic. Most of the times we will ask in the question paper. So we will wait for some more time. All of you ready with the running notes? It is important to draw some circuits and circuit symbols as well as the characteristics. So I will start the class now. So whatever we have discussed now is different characteristics of the SCR, okay, and how to trigger the SCR using UJT and different specifications, current ratings and volt ampere ratings, okay. So now we have volt ampere characteristics of diac. So already discussed we have the SCR. SCR characteristics we have discussed. So in the forward bias mode how it will be conduct and reverse conduction mode how it will be conduct we will discuss. So now the other device or the other component power electronic device which is diac, how it can be used as a in the AC circuits. So it will be mainly used in the AC circuits and what are the characteristics and how it will behave for a different power supplies. Okay, so now, so if you see in the diac, the name diode plus AC, it is a two term. It will have two terms. What are they? Diode plus AC. That means it is a diode. The function it will like a diode, and it is mainly concentrate. It will mainly concentrate, or it will be behave in the AC circuits only. Okay, and it will works on AC. It will works on AC, and it is a basically it is a five layer four junction semiconductor device. It is a five layer four junction semiconductor device, whereas SCR is a how many junctions? We have a J1 J2 J3, only three junctions are present. But for a diode we have a four junctions, and how many layers it will be there? Five layers are there. And if you cut this device into equal parts, the cut into the middle part like this, we have a, you can have two SCRs. You can they have a, you you will form a two SCRs cut like this. If you cut like this you will form a two SCRs, and but they are connected in back to back. They will connect in back to back. For example, if you see this is SCR is like this. So SCR is like this means PN device. It is a PN device. SCR1 is a PN device, and SCR2 is also a SCR2 which is NP device. That means it is connected back to back. So it is reverse direction. It is like this means you have to connect in like this. So it is forming two SCRs back to back. You can call as a two SCRs back to back. But what is the difference is without gate. Very important, this is without gate. So the diode can be switched off from off state to on state, either polarity of applied voltage. Either polarity of applied voltage means it may be a positive voltage you can apply, or negative voltage you can apply. Both is that is the reason you can interchange the terminals. You can also able to interchange the terminals. What are the terminals? Two terminals. So MT1 and MT2, and that means you can also interchange MT1 in place of MT2 and MT2 in place of MT1. So it is also one of the reason, because you can either polarity it will be applied voltage on, and it will be conducts in both directions. That is the reason diode AC diode both direction bidirectional device. It is a bidirectional device, and the most important device in the to trigger the track is DAC. So in order to trigger on the track, we will use DAC. Is it clear? So main purpose, the main usage of DAC is in order to trigger on the track. In order to trigger the track, DAC will use. And if you structure, if you see, so complete structure, it will looks like this. So MT1 is there here, MT2 is there, or you can also replace both of them. So there is no difference. Okay, so PN device, it is NP device. So it is connected in back to back. Two SCRs connected in back to back without gate. Without gate. So and it will be operated in AC. So why? Because AC is two direction, bipolarity. Two polarities is there. Positive polarity and negative polarity. Both polarities it will able to run. It will able to conduct. So that is the reason. So most of the times it is used in the AC circuits only. And you the if you have the M2 is positive with respect to MT1, so device is forward biased, junction J2 and J4 are forward biased and J3 is reverse biased. When the voltage is increased beyond the breaker voltage, the junction J3 breaks down and the device goes to high impedance state or low impedance to low impedance state. Is it clear? When the voltage is increased beyond the breakover voltage, the junction will break down and the device goes into high impedance state to low impedance state. That means it will conduct starts. It will conduct a start. So characteristics is similar to the SCR. The forward characteristics of DIAC is similar to the characteristics of the SCR. So if you see the characteristics of the diac is similar to the characteristics of SCR. Correct or not? Beyond the breakover voltage, it starts conducts. So below breakover voltage, there is a leakage current. You are blocking the state. You can call as a some leakage current will flow. And if you see in the reverse characteristics, what will happen? The reverse characteristics also same as that of the forward characteristics of SCR. So two possibilities of breakover voltage VBO1 and VBO2 because you can interchange the terminals MT1 and MT2. So mirror image, it will mirror image of the forward characteristics in the first quadrant and third quadrant. Okay. So if you see in the volt ampere characteristics, the SCR characteristics both in the forward direction as well as in the reverse direction is similar and they are mirror image to each other because we interchange the terminals. So the MT1 is positive with respect to the MT2 and MT2 is positive. If the MT2 is positive, MT1 is negative, and if the MT1 is positive, MT2 is negative, like this. So in the off cycle it will conduct and in the off cycle, first off cycle it will conduct as well as the negative off cycle it will conduct. Because that is the reason it is works in the AC only. So the breakover voltage for a diac is about 30 to 50 volts and the voltage drop across the device is 3 to 5 volts and the track operating as a operating characteristics as similar to that of the diac and it is termed as a gateless track. Diac is termed as gateless track. Is it clear or not? So the characteristics, if you see the forward characteristics of SCR as well as the forward characteristics of diac as well as forward characteristics of the track, all are same. So and what is the other term for diac is it you can call as a gateless track. You can call as a gateless track. So major purpose for a diac is to trigger on the track. So first application of a diac is the triggering device for a track, and also it is used as a lamp dimmer. You can call as a you can use as a lamp dimmer. That means you can dimming purpose on off something light glowing will be changed. The brightness of the light will be changed due by you are connecting the diac. Or also some track also used to in order to dimming of the lamp. Okay. So in the fast speed regulators, temperature controllers, universal motor speed controllers, proximity detectors in the industrial circuits for phase and heat control with TRIAC. So DIAC will be used. The applications of DIAC is the triggering device for TRIAC, lamp dimmer, fast speed regulator, temperature controller, universal motor speed controller, proximity detector, and industrial circuit for phase controllers. The track also used for the phase controller. So we will see in the next class. In the that will be heat control circuits also that are used with the track. So major disadvantage. What is the major disadvantage? It is a low power device. It is a low power device as well as there is no control. There is no control terminal. That is, there is no gate. So if you are not having any gate, there is no control over the power output. Correct or not? If you see in the SCR, the major advantage is that you have some gate. So whenever you require, you can on voltage, the output voltage you can on, and whenever you doesn't require, you can off. simply by connecting gate. Here the diag there is no gate, so that is the reason there is no control over the output voltage. So that is the other disadvantage. So there are the major two disadvantages. What are they? It is a low power device as well as it doesn't have any control over terminal. Okay, so the control terminal is not present in the diag. So the volt ampere characteristics we have already discussed. The SCR is same as that of your forward characteristics of a SCR. So here you can see the characteristics. So same thing we have already discussed. What is that? So whenever the forward breaker voltage you can turn on the device in the two ways. The SCR can be turned on in two ways by increasing the breakover voltage, and second one is the you are applying a gate terminal positive triggering or voltage to the gate terminal. So but in this case there is no possibility of the gate terminal, so you have to on by only switching over greater than breakout voltage. So add to cathode voltage or MT1 to MT2 or MT2 to MT1 voltage, you should increase more compared to the breakout voltage, then only it will be turned on, the diac will turn on. After turn on you will get a some current, you can call it as a here you can call it as a base current IB, but there you can call it as a latching current. So if you are increases the latching current greater than latching current, it will goes into forward conduction mode. Here you can call as a IB. So IB is you can call as the base current. That base current if you are increase more, then it will start conducting. Okay, so because there is no gate terminal, so there is no control over the this latching current and holding current. So this is over the disadvantage of the DAC. Okay, so if you see the characteristics and the reverse characteristics also same thing. Is the mirror image of the forward characteristic or for first quadrant characteristics, because you can easily interchange the terminal. So MT2 to MT1 is positive with respect. So this characteristics is MT1 positive with respect to MT2. This is MT2 is positive with respect to the MT1. That means MT2 is higher potential, MT1 is lower potential. So characteristics, if you see it is also same thing, because you are increasing the anode to cathode voltage or MT1 to MT1 voltage. So greater than VB2, then it starts to converge. Okay. So and here IB is positive, here IB is negative. So that is the only difference. You can see the characteristics. So there is no difference. Okay. So that is the characteristics of the dia characteristics. Okay. Next, volt ampere characteristics of the track or triode AC. So what is the terms you have present in the triac is tri plus AC. So triode plus AC. This is a triode. So the how many terminal you can call it a triode. Ode means terminals. Tri means three. So it is a three terminal device which is operated in AC, and it is the mostly widely used component or power electron device after SCR. So after the SCR, mostly you can use the track in the power control circuits. So, and the major drawback of SCR is that it can current in only one direction. Correct or not? If you see in the characteristics of the SCR, what will happen in the forward characteristic, it will conduct. In the reverse characteristic, it will not allow. It will blocks the current. So that is the reason they are used in the rectifier circuits. So this is the major drawback of SCR. That will be eliminated by using this track, because it will operate in four modes. Modes of operation of track is four modes of operation. So positive to positive, positive to negative, negative to positive, negative, negative. So there are four possibilities you can get by using a track, because the terminals are interchangeable here also, MT1 and MT2, and also some gate is also present. So there is a control element. There is a two terminals that they can be interchanged. So that is the reason they can be used in the four modes of operation. A track can be used in the four modes of operation. So, and reverse blocking characteristics and current cannot flow in the cathode to anode direction in the SCR. That is eliminated here. And the SCR can control DC power or forward biased half cycles of AC. However, in AC system, it is very necessary to control over both positive and negative half cycles. Is it clear? So, the AC circuits, you have to control over the positive half cycle as well as the negative half cycle. It cannot be done in the SCR, because in the negative half cycle, what will happen? It is off. So off means there is no control over the negative half cycle. But in the AC supplies, what will happen in the large amount of AC supplies, in the positive of cycle as well as the negative of cycle, you should control, because your order of the voltage or power levels are kilovolts or megawatts of power. So that should be controlled in the power electronics. So that should be controlled by the TRIAC. So this is the major advantage of the TRIAC. So and if you see the construction wise, the TRIAC, so they are connected in anti-parallel. So they are connected in SCRs connected in anti-parallel. Okay. So if you see the device structure, so device structure is same as that of your diagonal. If you see the device structure or a construction wise, if you see in the TRIAC construction is same as that of your DIAC. But what is the difference? Only one difference is gate terminal. So see here the gate terminal is present here. So PN and NP. So this is the NP and PN. So how many layers are present? You can see 1, 2, 3, 4, 5, 6. So there are the 6 layer device actually. The track is a 6 layer device. So how many junctions? One. So here it is a 1. So here 2. This is 3. So this is 4. This is 5. So this is a 5 junction 6 layer device. So it is a 5 junction. So it is a how many layers? How many layers? 6 layers and 5 junctions. So it is a 5 junctions are present in the track terminals. Okay. So and there are two terminals MT1 and MT2. They can be interchanged. Okay. So it can be interchanged, and some gate terminal is also there, and the SCRs is connected in anti-parallel, back to back or anti-parallel. Both are same. Okay. So and the working of track, if you see, so they can be have the how can be the track can be work means. So if your the terminal MT1 is makes contact with the layer N2 and P2, and terminal M2 gate terminals is having a G is present in the where N3 terminal. N3 means it is a layer 3. Okay, N3. So in the N3 layer it will be connected, and they can be interchangeable. So positive to negative one cycle, negative to positive. So in the place of anode, you replace with the MT2. Okay, so you can replace the A with the MT2. So and that is MT1 is positive, MT2 negative, or MT2 positive, MT1 negative, or MT1 MT2 both are negative, or you can have a fourth quadrant. MT1 is positive and MT2 is negative, something like that. There is a four quadrant operation. You can call it as a four quadrant operation. It can be done through track. So all quadrants it will be works. So because there is a combination, there is a two means there is a two square four combinations you will get. So four combination, all four combination it will be work, and it will be turned on the, and it is like forward conduction or forward direction of the SCR only. So the characteristics of track is forward characteristics of SCR in the all four quadrants. But so most of the times they will use only two quadrant operations only they are used. All four quadrant operations cannot be used. Most of the times only two quadrant. What are they? First quadrant and third quadrant operation only it is mostly used. The all four quadrant should not be used. So there is a problem. There is a problem. Some power dissipation problem is there. So that is the reason you have to use in the first quadrant as well as the third quadrant operation is mostly used. And the major advantages, if you see, the TRIAC is it's a bidirectional device, but DIAC also bidirectional device. There is no problem. So what is the other major advantage is it is conducting all four modes. It conducts in all four modes, and it is majorly used for the resistive loads. Majorly used for the resistive loads, as well as it is also used as a protection circuit. So it is used as a protection circuit for the power electronic circuits. Okay, in the power electronic devices, it is the device which is used, the track is used as a protection diode. It is used as a protection diode across the track. Next, other disadvantage the track has is, so it will be not suitable for controlling power higher highly inductive loads. So if it is the loads which are there have inductives, the inductive loads cannot be used for the purpose of controlling the these loads, whereas resistive loads it is very much useful, but inductive loads it is not much useful. And the power rating of the SCR is lower than the SCR. The power rating of track is lower than the SCR. Is the second advantage. And other disadvantage of triac is it cannot be used as a rectifier, because SCR can be used as a rectifier because forward direction it is conduct, reverse direction it will not conduct. But in the triac, both direction it will conduct, so you can't use it as a rectifier. That means you can't able to convert. Yeah. What is that? AC to pulsating DC. You can't convert AC to pulsating DC, and the triac mainly used in the AC circuits only. DC circuits it can't be used. So this is also one of the major disadvantage. Is it clear? So 3 to 4 disadvantages are there and 3 advantages are there for a track. So the major advantage is that it is used for the resistive loads and it is used as a protection circuit, and it is a bidirectional device. The DIAC also bidirectional device. So track is a major disadvantage is it is should not be used as a control rectifier, and there is a problem with the inductive loads. There is a problem with the inductive loads, controlling the inductive loads, and the power rating of the track is lower than the SCRs. Okay, so SCR can be handled much more larger power ratings. So kilowatts, megawatts of power only. Also, you can have the capability of controlling the SCR, but the track has only kilowatts of power. Only it will be able to control. Okay, so other that is the major disadvantages, and the applications if you see it is used as static switch, speed regulator, lamp dimmer, temperature control. I already discussed the same as that of DIAC applications, because you have a the DIAC operation and TRIAC operation both are same, but extra is these other two modes are added because due to the control element of gate. So static it is used as a switch as well as a speed controller, fast speeds controller, lamp dimmer, temperature controller. Okay, in the AC voltage stabilizers. Okay, they are also used in the voltage stabilizers. Speed control of single phase induction motor as well as the series motors, and phase level circuits or phase control circuits, and illumination level control. Okay, illumination control circuits. So they are the applications of track. So static switch, speed controller, fan speeds controller, lamp dimmer, temperature controller, AC voltage stabilizers, speed control of single phase induction motor as well as series motors, phase level circuits, and illumination level control. That means brightness level. So lamp brightness also will be controlled through this track. So most of the power electronics are projects. So projects based circuits, you have developed any circuit, the track should be used because to control the AC motors or generators, whatever the electric motors that with generators you can easily control through this track. So that is the reason most of the applications after the SCR the track is used. So majorly used electronic power electronic devices track after the SCR. Okay. So if you see the track characteristics already discussed, there are how many modes of operation? Four modes of operation. It is same as that of the forward characteristics of forward characteristics of SCR. So how if you are increasing the gate voltage, it will turn on quickly. So the gate voltage or the positive triggering voltage, if you are increasing, then it will switch over the very fast or quickly. So 0 amperes means slowly it will turn on. So some current you are applying means quickly. IGT is more greater than the IG1, so it will more quickly it will be turned on. So same as you can send in the PCR. So that is the reason I already told you that if you have the characteristics, if you learn the characteristics of SCR, it will be applied to the all of the power electronic devices. So if you see the characteristic, there is no much difference in the third quadrant also. So first quadrant and third quadrant characteristics are both are same. If you see, so BBO, BBO2, BBO1 is the this forward characteristics. Reverse characteristics also same as the forward characteristics, but the range of voltages of breaker voltage is different, VBO2. Okay, so the terminals you can see, and you can also have the characteristics in the second quadrant and fourth quadrant also, like this. The same characteristics also available in the second quadrant as well as the fourth quadrant, but these two quadrant cannot be used. Okay, both this quadrant are used mainly, this not used in the very much. So the applied voltage is, if the how we can turn on the SCR is same as that of the, you can also turn on the track. So if the MT1 is positive with respect to MT2, then what will happen? So for characteristics and gate terminally we have to apply some voltage, then it will turn on after the breaker voltage. Okay, after the breaker voltage it will turn on. So and the first quadrant you have to draw the characteristics with the MT2 is positive. Whereas in the third quadrant, MT1 is positive. That means MT2 is negative. So, so both ways you can convey. So both ways you can convey that. So if the MT2 is positive in the first quadrant, then MT2 is negative in the third quadrant, or MT1 is positive in the third quadrant. So like this you can have the characteristics. So this is the characteristics of the DIAC and TRIAC. Is it clear? All of you, respond. Ritesh, Vaishnavi, are you listening or sleeping? Sanjay, Harsha, are you listening? Sindhuja, is it clear?
Sir,
Is it clear or not?
సార్ మీ వాయిస్ వినిపిస్తలేదు సార్. మీ వాయిస్ వినిపిస్తలేదు సార్. ఇప్పుడు బ్రేక్ అవుతుంది.
Is it clear now?
ఎస్ సార్.
So whether you are able to just understand the concept.
ఎస్ సార్.
So what is the track?
It is a 3-terminal device.
Okay.
It works in 4 modes of operation.
Hmm.
It has 6 layers and 5 junctions.
Okay.
We can control it by gate. It is operated in AC. It it is a bidirectional device.
Okay. So how? What are the applications? Major
It is
application
used as a regulator.
used as a light dimmer circuits. Okay. Brightness level.
It is used as a regulator.
Okay. Stabilizer purpose. In the stabilizer, fan regulators. Just light dimming circuits. The controlling resistive loads. Correct or not? Is it clear, all of you? Others are not responding. Only Sindhuja is responding. She is listening very carefully. She is good. Hmm? What about two others? Kirti, the boy is not responding. Sanket, okay. So I will wind up this class today. So these are the class now. I will also post the video lecture. So please go through this video lecture. You will get some idea. So thank you all. We will leave the meeting.